What connects engineering rockets, sausage dogs, and YouTube? The answer is MIT Aeroastro PhD student James Dingley.
Fantastic. So good to see you all. My name's James. I'm a PhD candidate at the MIT Star Lab, and my focus is on space systems engineering with a specialty in space robotics. So I'll tell you all about what it means to be a systems engineer and to be involved in space robots. But to begin, I thought I'd like to introduce you to Derek. Now, Derek here is my 6th-degree freedom robot arm. He lives on my desk, and we get up to a lot of fun stuff together, testing out different engineering designs from the lab. Now, Derek is probably one of the smaller robot arms you'll see, at least in industry, but he's got all the right bits in the right places, and he's a good introduction to basically what a robot is. So robots are things that allow us to link together the world of computing, where we can have advanced decision making, and interactions with the real world, where we can have joints and sensors. It's made up of these joints here, which are electric motors able to spin independently a full 360 degrees, and those are linked together with linkages. By combining different joint angles with different linkage lengths, we can do pretty much whatever you like, be that assemble space stations or run a marathon. Now, he's also got a emergency stop button here, which I can press if he gets a bit too out of control, or if Derek's feeling a little bit tired, he might want to give it a press himself and have a break for the rest of our presentation. And now with that, I'll jump into my main talk about just what space systems engineering is and how I came here. So, I grew up in a place called Perth, Australia. For those of you who don't know, it's basically in the middle of nowhere, and it's also as far away from space and space robotics as you could possibly be. That said, it's a beautiful place to grow up. This is a beach just near where I lived back in Perth, and we'd go down to the beach every day, go for a swim, do some surfing, often try to avoid shark attacks. We had a fair few of those, but it was a great place to grow up. That said, we did have some engineering, except that engineering was all mining based. This meant I grew up in a town where everyone knew about engineering, was excited about engineering, but the only application for me was to dig rocks out of the ground. Really useful, but not what I was interested in. No, what I was excited about was space robotics. One of my first exposures to this was hearing about the Curiosity rover, which had just landed on Mars. And for me, that was amazing. We were exploring this alien world with rocks that we'd never seen before and trying to find the origin of life in the solar system. And not only was the science we were doing really cool, but for me anyway, the engineering behind how we were doing that science was fascinating. So this is the Curiosity rover, basically this almost entirely autonomous robot that we have trundling around on the Mars landscape. It's got all these different sensors, actuators, wheels, and I can basically pick up and look at rocks in this crazy, crazy world. So that was something that for me was amazing. And actually, when I was in year 12, we were given the opportunity to build whatever engineering project we wanted. And I decided that I wanted to build my own Mars rover. I didn't want to make a normal Mars rover. I thought, well, NASA can do really well with their wheels and trundling along. I want to make it a little bit different. So I made these Mars rover cubes. Basically, they are these boxes. They've got a flywheel in the middle. Think of it like a really fast fidget spinner. So we spin that up really, really, really fast, stop it, and then it's able to flip itself over by conservation of momentum. So it's able to flip itself and ideally explore Mars. For me, it went just a couple of blocks around the on the school level. But this was a really, really fun experience for me and helped solidify that I do want to be a space roboticist. And for that, I would have to go to university. Now, Perth has some excellent universities, but none of them study space engineering. But I knew that overseas, MIT, the Massachusetts Institute of Technology, would be the most amazing place I could study this. Not only did they teach space robotics, but also the engineers who had built the Curiosity rover, well, a lot of them had gone to MIT. And I realized this and I thought, well, best chance for me to build my own Curiosity rover is to go to the place that the engineers studied at. So I applied for MIT. Unfortunately, I didn't get in. So instead, I stayed in Perth at the University of Western Australia, but I never gave up on this dream to be a space roboticist. I worked out if I can't learn about it from my school, maybe I'll have to teach it myself or have some help learning it with some friends. And actually, I did two major projects back in my undergraduate degree. The first of these was I found that, sure, we didn't have an space engineering degree at school, but what we did have is a lot of people who were interested in it. So with some friends, created a club called the UWA Aerospace. And what we did is we tried to build our own rockets and try to build our own space missions. Our professors didn't know much about the practical aspects of rocketry, but they knew all about the theory of advanced materials and how to do really complex fluid dynamic simulations. So with these two theoretical areas, we were able to understand most of what it takes to build a rocket. The bits we didn't understand about how to actually put the pieces together, well, for that, we joined the WA Rocketry Society. Basically, it's this group of somewhat crazy engineers in Australia, and what they do is on the weekends, build a rocket, head out to the middle of the desert in Perth, which is honestly quite easy to get to, go to the desert, launch rockets, and then retrieve them and build even more bigger, insane rockets for the next weekend. So we joined that club, and by combining the knowledge of our professors with the knowledge of people who can actually build the things, we ended up doing some really, really fun rocketry projects. While I was involved in the rocketry team, I realized a little bit more about what it really means to be an engineer. Obviously, it's building things, but also in order to build those things, we need the money and finances to actually build these rockets and take them up into the desert. And so for that, I try to find some funding for the club, and realized that lots of people out in the community were interested in what we were doing. In particular, there were some schools around the area that had some engineering programs, but wanted us to come in and teach their students rocketry engineering. So that's what we did. We came in and we had a bottle rocket competitions we'd run with the students. We'd teach them about the theory of engineering, and in return, the schools would pay us some money, and we'd use that to buy more materials for our rockets. And occasionally, they'd have people who have extra materials that they could lend us. So by bringing in this extra member, the community, into the aerospace club, we realized that we could do even more cool stuff. The other project that I was working on during this time was a YouTube channel. So when I realized that I was going to be stuck in Perth for at least the next 3 or 4 years as I did my undergraduate degree, I was a bit disappointed, and I thought, why am I stuck in this place where no one does any real engineering? I told this to some of my friends and some of my friends' parents, and they said, James, Perth does some really cool engineering. Trust me. And I did, and it turns out, yeah, we have so much stuff going on in Perth. So because we are in the middle of because we're in the middle of nowhere, we have a lot of telescope projects that are able to look at the night sky with unparalleled detail because we've got so little light pollution. One of these areas was the Square Kilometre Array. Basically, this collection of radio telescopes out in the desert that can collect all their sensor data together and look at the cosmos in new wavelengths to see new things that we haven't seen before. I found the engineers who were working on it, and they said, yeah, come up and have a look. Uh, Also, literally the same beach I showed at the beginning. Um, because we have a lot of shark attacks in Perth, we need some way of protecting the people who go swimming. And one way of doing that is with shark barriers. And this image here is of one of the shark barriers that had been installed at that beach. And it turns out that that was not only protecting swimmers against sharks, but it was also really helping out the local ecosystem. It was providing a place for corals and other sorts of growths to live, and was just being really good at promoting a sort of fish sanctuary just off the beach. So I talked to the inventor behind that, did a swim along it, and explored what that means in a video. And of course, I looked at lots of other areas in Perth as well, with other areas of science and engineering. Even today, when I've been doing these YouTube documentaries all around the world, I think some of my favorite comments when people say, hey, that's just in my local area. I didn't know we did that. And I love that so much because that was why I got interested in making YouTube documentaries, to sort of see the world is amazing, and the world is amazing right where I live. You don't need to travel everywhere to go see it. So Spent my time in undergraduate building rockets and making documentaries. And then for my master's degree, I decided to apply yet again for MIT, thinking that I've got the good foundation now. Let's see if I can specialize a bit. And I was so fortunate that they said yes. I ended up joining the MIT Starlab to do a degree in space systems engineering. So, what is space systems engineering? Well, to begin, what's space engineering? I'd learned in my undergraduate degree that space engineering involved building rockets, and indeed, that is still a large part of the industry. But also, there's a reason we're building these rockets. It's to take things that we've built here on Earth and put them up in space, where they have access to a really unique environment. One thing that we send up is astronauts, people like you and me who do research up in space on things like the International Space Station. And they're trying to find out what it's like to live in space so that we can have future people living up in space as well as see whatever things we could do in zero gravity. But of course, another thing we also launch is satellites. These are basically a school bus-sized block of electronics, and these are able to either use big solar panels to stay charged, and sometimes they transmit radio data or information. If you've ever used internet on an aeroplane, then chances are some of that internet was beamed to you from one of these satellites. There are also remote communities, often in Australia, whose only way of getting internet is through these satellites. And actually, that was one of the first projects I worked on in my master's degree. Another thing we do with satellites is take photographs of the planet, and this gives a really unique perspective of what's going on. So again, really relevant for Australia is bushfire detection. And we've actually got a series of satellites now up in orbit that are able to take photographs and work out places that are likely to have bushfires and places that are currently having bushfires. So lots of important things going on in space. A space systems engineer allows all that to happen. So when I first joined engineering, I thought that the role of an engineer was to build cool things like structures, mechanisms, electronics, and maybe even writing some code. However, it's actually much more complicated than that. In order to build something, you need to know what you're building it. What are you even building? We need to be able to design it with a concept of operations. This allows you to sort of see, okay, my mechanism has to achieve this task, and it should probably be using motors and gears and maybe an extendable arm. But if you're designing that, well, who are you designing it for? So we also need to know what people want. This is called stakeholder analysis and allows us to generate a list of requirements, things that the project has to be able to do in order for the stakeholders to be happy. For me, back when I was doing my rocketry in undergrad, that stakeholder was often the local community, these schools who wanted us to teach them rocketry, and in turn, we're going to help support the club by us doing that. So we've got these stakeholders, we've designed a thing for them, we've built the thing, we need to be sure that it actually works. So another big area of systems engineering is verification, making sure that we built it correctly. And of course, we need to know that does the customer actually like what we've built for them? So we need to deploy the project, operate it, maintain it, and be sure that it's actually achieving the role that we set out to do. The role of a systems engineer is to really do these top four areas. We're interested in building the things, but really other engineers who are far more specialized than us can do that. We really want to be sure that they're building the right thing and the customer is happy with what we've built them. So to give an example, I'll talk to you about a robot that I helped build at with a bio-inspired robotics course. This is the MIT Cheetah. I didn't build this guy, but it did come from MIT. It's basically a robot that uses all the things we've learned from studying real animals, in particular cheetahs, to make a robot that can run really, really fast on really rough terrain. Here it's climbing up the steps in front of the MIT dome. So first up, as a systems engineer, we need to know, what do people want? If you have a dog at home, you might have gone hiking with it. And if you've gone hiking and your dog pulls its own weight, then you might have given it a hiking backpack to carry its food, dog poo bags, and maybe some of the stuff that you yourself don't want to carry. Well, it turns out roboticists are also interested in that, having robots that can traverse complex terrain by using legs, while also carrying heavy loads. So what do people want? Well, people want a robot that can carry heavy stuff and ideally can carry it in a really efficient way. The more efficient our robot is, then the less mass we need to waste on carrying heavy things like batteries that aren't really that useful. So that was what people wanted. We needed to design them an appropriate project. So for us, we decided to look at real dogs, and we noticed something rather interesting. Dogs come in different shapes and sizes. Some dogs, like the sausage dog, look like sausages, whereas other ones, like Great Danes, are a bit taller and a bit wider in different proportions. So our design, if you want to call it that, is we wanted to see how much of a sausage could we make our robot, and would that make things more or less efficient? We then built it. This is just a small scale version of the robot that we might one day eventually build. But on a small scale, we can design and test things and break stuff and iterate much, much faster than you would on something the size of a real dog. So the robot we built has these 4 sets of motors, just like the motors on Derek here, but these ones are positioned to give it legs. So we use these 2 legs controlled by 4 motors to run along a treadmill, and then we have some weights that are able to sort of simulate carrying different sorts of loads. So we built this thing, spent pretty much a full semester on it. We needed to be sure that it was actually going to work. So did we build it correctly? Well, it looks like we did build it correctly. It's able to run really fast on this treadmill. We were super, super happy with it. And then the front leg fell off. Okay, so maybe we didn't build it quite correctly. What we did is we took it back into the workshop, gave it some stronger legs, some better connections between the things. We glued it all correctly this time. And eventually we were able to get a robot that could run reliably. And indeed, we got 3 of those of different sorts of lengths, a small one, and medium one, and a longer one, more like the sausage. By looking at the different power that these motors were using, we worked out the energy that each of these different configurations were requiring to run. And we found out that, wow, actually the more sausagey, or the longer the robot is, then the less energy it's able to use. So does the customer like it? Yes, so we think they did. We had a really good design for a robot that uses much less power than we were expecting. So that was a good project for us. And by using this systems engineering toolkit, we're able to build it in a way that actually achieved the requirements. So let me give you another example. Now, I mentioned that I did a lot of videos back in undergraduate, and actually I've continued making these today. I run a YouTube channel called Atomic Frontier with almost 300,000 subscribers. As I've been making these videos while also studying space systems engineering, I realized a lot of the systems engineering things that I was learning, well, they're actually relevant for making videos as well. And I thought I'd give an example of a video I released just this weekend about how I use that engineering method to make the video. The video itself is called Industrial Robots Are Nearly Perfect. I went to BMW, the car manufacturer, and had a look at how they use robots to help build their cars. So what do people want? Well, in this case, we didn't just have one stakeholder we cared about, we actually had 3, and I had to balance all of their requirements in order to make a good video. The location team, the people who were letting me onto their site, was BMW. The reason they let me on their site is because they wanted me to show people all the cool work they're doing, while also helping out the planet with some of their sustainability initiatives. Students, people like me who are studying robotics, well, they wanted to learn about robots. So I needed to be sure that the video could communicate effectively all the key requirements of building robots. And finally, because this is a public YouTube channel, I really need to make sure that people who aren't necessarily interested in robots, I had to be sure that these people were entertained somehow, that they could enjoy watching the video, even if they're not one of these first 2 stakeholder groups. So I then had to design the video based on those requirements. For me, a big part of my designing phase is writing a script, and I do that by first up doing a lot of research. So I consulted robotics textbooks, and because I'm very fortunate to be here at MIT, there are some incredible robotics experts available here as well, including literally the same people who wrote those textbooks that I was basing the script off of. So I talked to these people and got a better idea of the theory behind what I was going to be communicating. I also did some camera tests. So this is working out if I can communicate things in the right way and if that's going to be interesting. Derek here was a star of that documentary, and I had him picking up different objects using a very large knife. in this camera test, I realized that his very large knife could actually be even larger. And also I had this really healthy collection of different food groups at the bottom there. I had some apples, bananas, and of course a donut. But I worked out, hey, donuts are really bright and colorful, and I want to eat donuts, so maybe I could replace this entire thing with a huge collection of donuts. So, had that design of the video, came up with a script, and I knew the key scenes I'd be talking about. The next step was to go out and film it. So went to BMW, saw their facilities, which were amazing. One of the really cool things that happened in this video is that the engineers who ran the facility were the same people who were taking me around it. And because of that, they were the sort of highest in terms of safety engineering. And when I said, hey, could I go see this? Could I see this part of the facility? They were like, yeah, of course you can. So we got to see some incredible behind the scenes stuff. We had the cars literally moving right past me as I was talking about them. Of course, we filmed some other scenes out in nature. Derek, we took him, literally hiked him into a beautiful national park, and you can see he's got a much bigger knife this time and a huge pile of donuts. So we were happy with that scene. And of course, I then came back home to Boston and did a lot of editing. If you make videos yourselves, the software I use is Premiere Pro for my main editing and After Effects for the graphics. And in these graphics, I was able to bring across a lot of the stuff that BMW were asking for. Things like talking about their supply chain and their customers and the networks that are involved there. So built the video. Now to be sure, did I build it correctly? Fortunately, by doing videos, I'm able to send little snippets out to people to get their opinions before I publish it for real. So I sent it to BMW. They wanted me to talk a little bit more about how they do packaging. For my student audience, well, I didn't send it to all the students I know, but I did reach out to one of my professors, Professor Sangbei Kim. He teaches robotics here at MIT, and he's far more experienced than I am in teaching about robots. So I thought he'd have a really good insights into if I taught robots correctly. He said, looks good, but wanted me to talk about some extra stuff about safety. So I added that into the video. And in order to support my channel, I run a Patreon page. Basically, people can see the videos a little bit early, and they actually become a really great public audience for me. So I send it to these people, they look at the video and say, great, I want to see more donuts. So I actually ended up adding in 2 extra animations just showing donuts. So I was pretty sure I built it correctly after I had it reviewed by these people. But does the customer actually like it? Well, I published the video over the weekend, and I've had a couple of really amazing comments. I haven't got feedback yet from BMW, so I'm not sure how that customer liked it when it went live. But in terms of the student audience, I've got a comment that says, you explained the limitations of robots really well. That's fantastic. That's exactly what I was going for. And in terms of the general public, beautiful and polished video. It's cool to see me go to other places and be more professional. So 2 amazing comments suggesting that, yes, I did meet these requirements I set out to achieve. And of course, because I'm an MIT engineer and a little bit of a nerd, there's a huge amount of statistics that I can also look at behind the scenes. Things like how many people are seeing the thumbnail, how many people are actually clicking the thumbnail, and how does that result in the views that people are doing. So we're able to do this final review and have the customer actually enjoy it. Finally, I'll talk about one final project that I'm working on. Now, I don't just make videos in my time, I also have a real PhD that I'm doing, and that PhD is in a project called the Orbital Locker. So the idea behind Orbital Locker is that we have a constellation of satellites. That means lots and lots of these satellites in different orbits around the Earth. Some of them are able to see places like Australia, others are then positioned to see places like America. And this constellation of satellites are made up of what we call the orbital locker. So lots of orbital lockers existing, and each of these have a collection of basically Lego bricks inside them, with these Lego bricks performing different functions of a new satellite, maybe like a camera module or things like an extra radio or more batteries. And now on demand, the orbital locker uses its robot arm, which is installed inside it, to pick up these Lego bricks, plug them together, and build new satellites, and then basically just throw them out the airlock and have new satellites deployed in hours rather than the current method, which might take a year to actually get a satellite built and launched. So this is the project that I'm working on at the moment. Haven't quite finished it yet, but again, I'm using that systems engineering process. I first found out what people wanted. I talked to engineers at NASA about what they could use a space robot for. I designed it. In this case, the way engineers do a lot of designing is with computer-aided design. So I made a 3D model of what I wanted to build and was able to review this and iterate it over time. And most recently, I've been building the thing with structures, mechanisms. So this here is a small-scale prototype we have working. We've got those Lego brick-like objects, and they're being moved around by a gripper hand. Uh, what I'll be doing next is finishing the build, check I built it correctly, and hopefully deploying it to space. In the immediate term, maybe to the International Space Station. In the longer term, maybe around with real orbits and as a real satellite. But of course, that's all stuff that I've got to do in the future. For the moment, that's all ahead of me. I've got 1.5 more years of my PhD. I've been currently here for 2.5, so I'm excited to see what happens. And with that, I'll turn over to you guys. I'd love to answer some of your questions.
Thank you so much, James. We have some great questions in the Q&A from Nord Anglia students who are wondering about robotics and wondering about YouTube. So let's get started with the questions about robotics. So Nico from Boston is wondering if you have ever participated in any competitions with your robots. Did you compete when you were in high school?
Yeah, really good question. So unfortunately, I haven't competed in any robots competitions. Apart from when I was a kid and me and my friends tried to build some really cheap battle bots, where we basically strapped knives and other utensils to, I think it was a Roomba, to try get them to fight each other. But I did help out with the first robotics competition. I'm not sure if it exists in America, but in Australia, it's a competition where you have to sort of build a robot and get it to, I think it was pick up objects and throw them. I wasn't one of the engineers on that. I was just helping out with the team in my university. But yeah, very, very fun
Yeah,
question.
got it. So if students want to start out in robotics, maybe they can ask their teacher and do it safely under the supervision of an adult.
Yes, that's a good idea as well.
We have a follow-up question from Rayan, and Rayan's wondering, is there a way to start my robotics career at the age of 11?
Oh, that's a good question, Ryan. That's very exciting. And yes, you definitely can. Uh, if you have access to, well, one of the really good robotics toolkits to start out with is Lego Mindstorms, I think they're called. So your local library might have a set of these, or one of your teachers might be able to get a hold on that. And that gives you some really basic motors and gears, and you're able to plug these together just like Lego. And then they've got a really nice system to program it, which you can do with the computer. If you don't have access to a thing like Lego Mindstorm, then there are often simulators online where you can program a robot, but do it in a virtual environment. And actually, I hadn't realized this until I came to MIT, but most of robotics engineering is actually being done in a computer. So even if you don't have the real robot to play with, then doing all the simulation stuff is 90% of the way there.
Okay, that leads us to a couple of follow-up questions from Nord Anglia students who are wondering, what software do people use for that?
Oh, it is honestly, it's a huge mess. Every single robotics course I've done at MIT as well as back home in Australia, every professor has their own favorite robotics package to use. Uh, One of the most common ones in industry is ROS, that is ROS, and that's a really easy way to plug in lots of the different sensors and different controllers and get it all working in a mostly reliable way. So ROS is what's used in industry, but in practice in academic setting, everyone has something different.
Okay, got it. And now we have a question from Isa, and Isa's wondering, when you were starting to build robots and starting out in mechanical engineering, did you have help along the way? Were there people helping teach you these things? Were you building things with other people?
Yeah, really good question, Isa. And yeah, it is so important to have people helping you out. I really learned that when I created the aerospace rocket team because I couldn't have done any of that without my huge team of people helping me out. And it turns out, yeah, you need that as well in robotics. So I've been really fortunate to have a series of professors who are excited about robots and willing to share the stuff they're doing. So even at UWA, we had a professor that had similar robots to Derek here, and we were able to program those in a class setting, We had teams of three of us all programming the same robot and trying to get it to do really simple tasks. And then even today, as a PhD student, uh, PhDs are often quite solo affairs where you're working on your own project in isolation. But for something as complicated as a robot, I've actually got a team of 5 or 6 students who are helping me out, all working on a different area of the robot. Some helping to build it, others helping with programming.
Got it. And speaking of that teamwork aspect, does that translate to space robotics as well? Do people work together on those sorts of robots and satellites too?
Oh, of course, the teams involved in modern robotics are enormous. We have places like NASA and the NASA Jet Propulsion Laboratory, which are the groups really building these robots. They might have hundreds or maybe even thousands of people working on a project. And for that, you need really good engineers, but you also really need really good systems engineers because it's not only you working on your own project and you know what's going on, but actually you have all these people and you need to know exactly what they're doing and how the things that one group are doing interface with and interact with what everyone else is working on in the project.
So there's a huge component of communication there and talking to other people as well. And now we have a question from Trisha, who's wondering, and maybe this is along those lines. You were describing your running robot and that scale of like sausage size thing versus energy use. Trisha's wondering, what gave you the idea to think about the dogs and the sausage shape in the first place? Was it trial and error? How did that come to be?
That is a really good question, Trisha. Uh, How did we come up with that robot idea? The course we were studying for this, the course we were studying at the time was in bio-inspired robotics. So this idea that you're able to take things from biology and that we see in nature and apply these to a robotics context. For example, the cheetah robot, a lot of the mechanisms behind that, and in particular its spine, which is quite flexible, those were all taken from real biological systems. And the course we were studying was trying to get us to incorporate some of those areas. So we wanted to build something based on a real animal. We knew that engineers were getting more and more interested in dogs. And so we knew we wanted to make something that looks like a dog. In terms of why it was more sausagey in shape, we just wanted a variable to vary and see if it actually affected things. We thought there might be something to it, but we actually had no idea how much of an impact it would have. And that's often a theme in engineering is that people are just trying stuff out that sounds cool or sounds interesting, and then realize, oh my goodness, by playing with light bulbs in this one weird particular way, we accidentally create computers. So there's a lot of that stuff going on in engineering. I'm just glad that this sausage one actually worked out.
Me too. So that leads me to a follow-up question from Aryan. And Aryan's wondering, you've mentioned this process of trying out these new ideas. And in the sausage case, like it worked. You guys tried it and it was a good idea. But what happens when it doesn't work? What happens when these ideas fail? Does it ever make you feel like giving up?
Ariane, that's a really good question. And yeah, often it does. And one of the downsides of doing sort of short talks and stuff is that I often people don't talk about their failures. And I've had so many failures throughout my life. I've had videos that I've tried to make, spent months and months editing, and then aren't exciting. Or in the robotics space, I've had so many robots fail. For example, I talked about the Orbital Locker project. Well, that's actually the third or fourth iteration of the robot that we've been trying to build. We started out with an gripper arm more like Derek here, but we found out that it wasn't able to reliably pick the modules up, and then actually programming it was really, really difficult for us to do. We then moved over to a different gripper mechanism and a different way of moving things around. That failed as well. It ended up just freezing up on different joints. Basically, would get halfway along its move space and then stop. Uh, and yeah, it was always in the back of my mind, like I should just quit the PhD and do something easier. However, I talked to my friends, talked to my professors, and they're like, "Oh, well, of course, you've had one small failure. Yeah, you've got to give up now." Like, no, don't do that. You've worked so hard at this. Everyone fails at things. My professors have failed at things. Like, you can keep going and keep doing really cool projects. And getting the inspiration from the people in my lab has been really important to that.
Of
In
course.
terms of the videos that I've abandoned midway through, well, sometimes I have actually abandoned those ones. Other times I realize, okay, most of what I filmed here isn't great, but maybe there's something I can salvage. Most recently, I did a video about the AT&T Long Lines network, which is a series of radio towers all around America that communicate with each other to, or at least used to provide the internet. Today we do it with fiber optic cable. Uh, but talked a little bit about the project. It wasn't quite interesting enough. So rather than abandon the project, I realized, okay, I need to dig into this, make it more interesting. Called up someone who actually owns one of the towers, was able to go onto site, climb up it, film it there, and it became, I think, one of my most successful videos ever because I didn't give up, but I pivoted a little bit to approach it from a different angle.
Wow. And I'm glad you did. That is super cool. So I want to ask one more question about robotics before we start moving on to the many YouTubing questions that the students are asking. And so Abraham is wondering, you showed us Derek in the beginning and you had this beautiful choreographed interaction. Abraham's wondering, did you build Derek? And if so, how long did it take you to build Derek?
Oh, I did not build Derek. Thanks for that, Abraham. Yeah, Derek is a professional grade robot, one of the cheaper professional grade robots, but he is a professionally built robot. And that has the benefit that we have electronics engineers who deal with the electronics, mechanical engineers who deal with the mechanical side of things. I am an everything engineer, which means I'm not very good at any bits of that. Um, I did program it. And that's actually, again, slightly easier than you might expect. There are two ways to program, technically three ways to program robots. You can manually type in all the joint angles you want to be using, and that can often require a little bit of trial and error. You can get a computer to do that for you. You basically say, I want to go from this location to this location, and the computer is able to make very small movements in each of the different motors to move you towards the goal. And the final way to program a robot, which is what I did, is there's a little button on the side that allows you to, it goes into kind of like free moving mode, where I can lift it and move it around and just guide it to different places. And that's often what we do with collaborative robots, robots that work directly with people. So that's actually what I did. I recorded my introduction and then choreographed with Derek to move it around.
That is really neat. Okay, so now we're going to ask some YouTube questions from the Nord Anglia students, and we're going to kick it off with Nikhil. And Nikhil is in year 5, and Nikhil's wondering, how did you become a YouTuber? Did you know you were going to become a YouTuber?
Uh, Good question, Nikhil. I still ask myself that, honestly. Uh, I don't think I ever knew I was going to become a YouTuber. I always thought that I wanted to do space robotics, and I knew I was interested. I knew I was interested about science. I actually really started making videos as a way of practicing stuff before science class. It's only later that I really applied that to going around Perth and exploring it. Um, and again, that was always as a method for me to get into interesting places and see what was actually going on in my community, rather than as to become a YouTuber. Um, However, that slowly started snowballing when I was releasing these videos purely for my own entertainment, and then more and more people watching them. First, just my friends, then other people at my university, and eventually was people from not even Perth, from all around the world saying, "That's really cool. I didn't know Perth was like that. I want to come visit now." Uh, a really big moment for me was when the YouTuber named Tom Scott. He's a British guy. He also goes around the place talking about engineering behind different things. He ran a competition where I was send me one of your videos and I'll see if I want to publish it on my channel. So I did. I gave him a picture of video that I wanted to film. Uh, he said no for that one. Then I did it again the next year. He said no for that one. Did it again the year afterwards, and he was like, "Yeah, that sounds great." So that third time round, he published one of my videos onto his channel, and then a huge amount more people went and saw my stuff, and that eventually gave me the sort of more financial support to actually do these videos, not professionally, but at least more of a serious hobby.
Got it. And a follow-up question from Peter from Boston. And Peter's wondering, he dreams of being an influencer himself and making these videos one day. How long does it take from having a YouTube video idea to having a published video?
Oh, Peter, nice. So that really varies. The video that I'm currently editing, and by currently editing, it is on my second monitor right now because I'm midway through editing it. That one I started filming a year and a half ago. It won't be published for another couple of months. Another video I'm working on, again, it's been a year, 2 years on it. When it's a video that needs to really move really quickly, maybe we'll take 2 or 3 months. So for the BMW robotics video, because they wanted it that quickly, that one only took me 3 months. So it does take a time. And there's not just the time to make the video, but there's also time to go from wanting to be a YouTuber to sort of being a YouTuber. So Peter, it's awesome you want to do YouTube and stuff, but it is going to take some time. For me, it took 10 years for me to go from making videos to having 100 subscribers. I'm sure you can do it faster than me. I'm very slow at everything, but really enjoy the process of making videos. Be excited about making the videos first, and then think about being a YouTuber if that starts to snowball in the way that it did for me. But yeah, keep at it. I'm really excited to see the stuff you do, and glad to hear you're in Boston.
That is great advice. And that actually addresses a lot of the things that a lot of other Nordic English students are wondering in the chat. So I want to leave us with one last question before we have to start wrapping up from Isa. And Isa's wondering, how can I start making explainer videos? I don't have the ability to go to factories, so where do I start?
That's an excellent question. And yeah, I didn't have the ability to go to factories either, at least at the beginning. So for explainer videos, a lot of the explainer stuff you can do at your own home. You can explain how things that you see in the real world around you actually work. So I don't know how a modern electric stove works, or how ovens keep the same temperature, or anything like that. So you can do an explainer video about how that works, showing the really cool real world stuff without even leaving your house. Of course, the stuff that goes along in your community, so you can talk about that. For a lot of my early videos, I went and stood in front of the bell tower in Perth, or I stood in front of a factory. I talked about it there without even going inside, and I would just show some animations or some photographs about what was going on. Of course, something that I've been really surprised about is that people are super willing to let you see their cool stuff. If you show an interest in what they're doing and you show that you've done a bit of research behind it, you'll be surprised about people just letting you in to do things. For example, one of my early videos, I talked about using silver as a way to build better bells. And for that one, I went to the Perth Mint. I literally walked up to their front door and said, "Hi, I am a student. I'm trying to make a video about how silver works. Can I come inside and hold one of your silver ingots and like hit it with a spoon?" And they were like, "That's a weird request. Give us 10 minutes." They went to talk to their security guys, found a security guy to follow me around, and then I literally was hitting a piece of silver with a spoon. And this is back when I had about 50 subscribers. So you can definitely go into places, even if you're not a established YouTuber at the moment. Yeah, you just got to ask and be excited and be nice to these people. Yeah, good question.
That is really, really good advice. Now, I wish we could ask the many, many, many more amazing questions in the chat, but unfortunately, we have to let everyone go. So before everyone leaves, I just want to tell them that they can find recordings of today's abstract with James on YouTube and Global Campus soon, and that we also have some really exciting abstracts coming up as well. So I'm looking forward to seeing you all there. And now, before we go, I'd like to thank you all for joining us today. Thank you to all the students for asking such wonderful questions. Like James, I'm really excited to see your YouTube videos after this. And I wanted to thank the MIT Nord Anglia Education Collaboration for making this series possible. And thank you, of course, James, very much for sharing your curiosity and research with us today. Thank you so much. See you all next time. Goodbye.